So we've talked about different ways to measure the center of a data set and the spread of that data set. Now we want to talk about the quartiles and IQR, or interquartile range, of a data set so that we can understand what they can tell us about our data. So the easiest way to explain quartiles and IQR is to look at a data set. Let's say that we have this data set here. There are 18 values in this set, ranging from 66 to 75. And we're going to say that this data represents the golf score of 18 golfers. So maybe the golf course is a par 72 course. The best golfer shot a 66, and the worst golfer shot a 75. So we have 18 golfers. This is our data set. And the first thing we want to say is that this idea of a quartile is related to what we already know about the median of the data set. So if you remember when we talked about median, we talked about it as the center of the set when we ordered the set from smallest to largest and found the center value. So let's start there. Let's think about the median. If we look at this data set, there are 18 values in the set, as we said. And so we have here the lower 9 values and the upper 9 values. Therefore, we know that the median is found by taking the mean of these two center values here. So if we take the mean of these two values, we would add 69 and 69 and then divide by 2. And of course, the result there will be 69. So the median here of this data set is 69. Now, when we talk about the quartiles of a data set, we usually talk about the first, second, and third quartiles. And in general, just at a broad level, you want to think about the first quartile as the median of this lower half of the data. You want to think about the third quartile as the median of the upper half of the data. And you want to think about the second quartile as being equal to the median. So we can refer to the first quartile sometimes as Q1. Sometimes we'll refer to it as the first quartile or the lower quartile. So we'll call it the first quartile, or we'll call it the lower quartile. We can also think about it as the 25th percentile of the data. On the other hand, the third quartile, we'll often call it Q3, or the third quartile. So instead of the first, we'll call it the third, or we'll call it the upper quartile, and we can think about it also as the 75th percentile of the data. And then the median here, we call that the second quartile, or Q2. So Q2, or the second quartile, instead of the lower or the upper quartile, we would say that this is the median, because the second quartile is equal to the median. And we would also refer to this as the 50th percentile, because in the same way that the median divides the lower half of the data from the upper half of the data, meaning that 50% of the data points will fall below the median and 50% of the data points will fall above the median, and therefore it's the 50th percentile. In that same way, 25% of the data points will fall below the first quartile, whereas 75% of the data points will fall below the third quartile, or below the upper quartile. So the upper quartile divides the lower 75% of the data points from the upper 25% of the data points. The first quartile divides the lower 25% of the data points from the upper 75% of the data points. So these are our three quartiles. And one of the reasons that these values are interesting to us is because they lead us to what we call a 5-number summary. And the 5-number summary gives us a really good picture of the center and the spread of the data set at the same time. So in the past, we looked at the center of the data set as mean, median, or mode, and then we looked separately at the spread of the data set as the variance or standard deviation. But the 5-number summary kind of gives us a picture of both the center and the spread at the same time. So that 5-number summary is always going to include the same 5 values. It'll include the minimum and maximum values from the data set, so the lowest value and the largest value. In the case of this data set, of course, that's 66 for the minimum value here, and 75 for the maximum value. It'll include the median, which of course we're already familiar with. And for this data set, we already calculated that median was 69. And then it'll include the first and third quartile, or the lower quartile and the upper quartile. And without even calculating the lower and upper quartiles for this particular data set, you can already start to get a sense that this 5-number summary gives us a pretty good picture of the center and spread of the data set, because not only do we have the median as the center, and we get the full range from the minimum to the maximum value. Let's go ahead and say, while we're at it, that we define the range of a data set as being equal to the maximum value minus the minimum value. So in this case, the range of the data set is 75 minus 66, or in our case, a range of 9. So we get the minimum, the maximum, the total range. We can see the center as the median. And these Q1 and Q3 values give us a picture of the middle 50% of the data set, because we know everything below Q1, below the first quartile, is the first 25% of the values in the set. And we know everything above Q3 is the last 25%, or the greatest 25% of the values in the set. But everything between Q1 and Q3, between the first and third quartiles, represents that middle 50% of the data set, of the values in the data set. And so those two values taken together, Q1 and Q3, give us a little bit of a picture of how tightly clustered the data is around the median. If the difference between Q1 and Q3 is fairly small, then we know that most of the data is tightly clustered around the median. But if the difference between Q1 and Q3 is large, then we know that the data is more spread out. So this 5-number summary given by these quartiles here is just another way to get a sense of what our data set is doing. Now, while we're here, let's go ahead and talk about how to calculate these quartile values. We already know how to calculate the second quartile because it's equal to the median, and we know how to find the median. But how do we find Q1 and Q3? Well, the answer to that is a little nuanced, because technically there are different ways of calculating the first and the third quartile, and they're not always going to give exactly the same answer. There's no universally agreed upon method for finding the exact value of Q1 and Q3. Just know that any accepted method we use is still going to give us a good approximation of what Q1 and Q3 actually are. One of the methods you can use for calculating these two quartiles, and maybe the most straightforward one, is to start by considering whether the original data set has an even or an odd number of data points. So in this case, this data set has 18 data points. So we have a data set with an even number of data points. If there are an even number of data points in the original set, then of course we already know, as we saw here, that the median is going to be found by taking the mean of these two numbers in the center. Because with an even number of data points, the data is going to split into two halves perfectly. In this case, we have 9 values in the lower half and 9 values in the upper set. So of course the median is going to be found by taking the mean of these two middle numbers. And then in order to find the first and third quartile, we can just look at each half of the data set and find the median of the lower and upper halves. So if we just look at the lower half here, starting with this lowest value, 66, and going up to this 69 value right here, there are 9 values now in this lower half. We can consider the median of these 9 values. Well, of course, if we have 9 values and we're looking for the median, we know we're going to have 4 values on the low side of this half, 4 values on the high side of this half, and then the median is this 5th value in the center right here, 68. And then we would consider the same thing with the upper half. The upper half contains 9 data points, ranging from this 69 value right here up to 75. So if we ignore the first 4 data points, 69, 69, 70, and 70, and we ignore the last 4 data points, 71, 72, 73, and 75, the median of this upper half is this value here, 71, and we can fill in our 5-number summary and say 68 and 71. Now, once we have Q1 and Q3, going back to what we said earlier about the 5-number summary, The difference between the first and third quartiles gives us a picture of how spread out the data is around the median, because what this 5-number summary tells us is that 50% of all of the values in the data set fall between 68 and 71 around a median of 69. That gives us a sense of how tightly clustered the data is around the median. And that value is important. That's the interquartile range that we mentioned at the beginning. The IQR of a data set is equal to the difference between the third quartile and the first quartile. So in our case, 71 for the third quartile minus 68 for the first quartile, or 3. So the interquartile range, or the IQR of this particular data set, is 3. It's Q3 minus Q1, the difference between the first and the third quartiles. So that's what our 5-number summary looks like. That's how we calculate Q1, Q3, and the median when we have an odd number of data points in our set. But what about if we have an even number of data points in the set? So this is the same data set, except for the fact that we have removed one value of 68 from the set. So now we have 17 golf scores instead of 18 golf scores. We have an odd number of values in the data set. And one common method for computing the first and the third quartiles when we have an odd number of data points is to, again, first find the median. So if we look at the lower and upper halves of the data, because we have 17 values here in the set, we've underlined the first 8 and the last 8, leaving us with just this center value here of 69 as the median. And one method for computing Q1 and Q3 when we have an odd number of data points is just to exclude this median value when we calculate Q1 and Q3. So excluding the median, we just look at this lower half of the data, these 8 values here, and we find the median of these 8 values. So looking at the median here, we have 4 values, 66, 67, 67, 68, and then 4 values, 68 through 69 here. So the median should fall right here. And we know, of course, that that means that we are taking the mean of these 2 values here. And so the mean of these 2 is 68, and the first quartile will be 68. To find Q3, the upper quartile, we consider just these 8 values. We know that the median should fall between the lower 4 values and the upper 4 values, so right here. And therefore, we know that that means that we are taking the mean of these 2 values, and we get an upper quartile of 71. So in this case, removing that value of 68 didn't change the value of the median or Q1 or Q3. All 3 values stayed the same. But of course, that won't always be the case. So these methods that we showed here to calculate Q1 and Q3 when we had an even number of data points or an odd number of data points, you can always use these methods. They'll work. But other methods sometimes have us include this median value here when we calculate Q1 and Q3 instead of excluding it, as we did with our method. Sometimes the method for an even number of data points up here will have us calculate this median and then include this median as if we had an extra value of 69 right here, and then go ahead and find the lower and upper quartiles. So there are slight differences, but as you can imagine, they're always going to produce fairly similar results. So the most important thing here is just understanding what the first and third quartiles are, how they fit into this idea of a 5-number summary to give us an idea of the center and spread of the data set, and at least one method for calculating the 3 quartiles. And of course, we calculated these quartile values by hand, but we can also use computers to help us find these values, especially as the data set gets larger. For instance, you can use the quartile function in Excel to calculate any of the 5 values in the 5-number summary. The quartile function will just ask you for your array, which will be the range of cells where you have your data set in the spreadsheet, and then for the quartile that you want the function to return. And so you would enter the array and then either the number 0 if you want the minimum value, the number 1 if you want the first quartile, or the numbers 2, 3, or 4 if you want the median third quartile or maximum value of that array, of that data set. So instead of trying to do this by hand, if we had inputted this entire data set into Excel, we could have used the quartile function, highlighted this data set, and then input the number 1 into the function for Excel to return to us the first quartile, 68, of this data set. So the last thing we want to say is that it's very common for us to use this concept of quartiles to identify outliers in the data set. We talked a little bit about outliers before when we talked about measuring the center of a data set, but determining which values in the set technically qualify as outliers can be more of an art than a science. But one method that people use is to employ these quartiles to give sort of benchmarks for outliers in the data set. And so sometimes we will say that any value in the set that is lower than the first quartile minus 1.5 times the IQR of the data set will be an outlier in the data. Or similarly, any value that is larger than the third quartile plus 1.5 times the IQR, that we'll consider any value larger than this value to be an outlier on the upper end of the data. So you can imagine with this data set right here, we said that the first quartile was equal to 68. So let's say 68. And then we'll say minus 1.5 times the IQR, which we calculated to be 3. So we have 68 minus 4.5, which gives us a value of 63.5. And so by this method, if we choose to use this method for determining outliers, we would say that any value less than 63.5 would be considered an outlier of this data set. So if we have 66, 67, 67, all the way to 75, if this is our data set, anything less than 63.5, we would consider an outlier. And similarly, on the high end, if we take Q3, which we know is 71 for this set, so 71 plus 1.5 times an IQR of 3 is 71 plus 4.5, or 75.5. So any value greater than 75.5, we could consider to be an outlier for this data set. Again, this isn't some objective, universally accepted standard for outliers. It's just one way that we could maybe set some parameters to start getting an idea for what would we even consider an outlier on the low end or an outlier on the high end for a data set like this one. It sort of gives us some boundaries, some gates around the data set, a sense of which values are unusually low or unusually high given the rest of the data that we have. So again, a lot that we can do with this concept of quartiles and interquartile range, but all of this information is really just more context around the center and the spread of a data set.